The pathogenic organisms that the disinfectant claims it is effective against must be EPA registered. When you hear the term hospital-grade disinfectant, that refers to a disinfectant that is effective against a select number of bacteria. The two common disinfectants used are quaternary ammonium compounds, or quats, and phenolic disinfectants, or phenols. Quats are good all-purpose disinfectants. They combat a broad spectrum of disease and odor-causing organisms. Quats also tend to be less expensive than other types of disinfectants. Phenolic disinfectants are also effective against a variety of organisms as well as bacteria that causes tuberculosis, but are higher in toxicity and irritation properties and have a distinct odor. Phenolics also lack detergent properties and do not contribute to the wetting and penetrating functions of a product. Phenols are inactivated by non-ionic synthetic detergents, so although they are not manufactured in such combinations, improper procedures used by the janitorial worker can lead to accidental mixing and poor disinfectant results. This can be avoided by properly cleaning equipment and cautioning employees not to mix anything but water into a disinfectant cleaner. Phenols are preferred in many healthcare settings where blood spills and other infectious bodily fluids are more commonly encountered. Phenols are recommended to help cleaning contractors meet OSHA's Occupational Exposure to Blood-Borne Pathogens standard. OSHA's blood-borne pathogen standard states that spills of regulated body fluids must be decontaminated with an appropriate disinfectant to prevent infection by blood-borne pathogens, primarily hepatitis B and AIDS. Sanitizers are designed to reduce the level of microorganisms on a surface to an acceptable level. Sanitizers can have either an alkaline or acid pH. There are many different types of sanitizers. The two most common types of sanitizers are quaternary ammonium compounds, sodium hypochlorite, also known as chlorine. They don't need the dwell time of a disinfectant, which is why they are ideal for a spray and wipe procedure. Products used to disinfect or sanitize in a solution are often termed microbiocides. Enzyme and bacteria cleaners are composed of living bacteria and/or enzymes that break down and liquefy organic soils like fat, proteins, carbohydrates, and grease, while simultaneously eliminating malodor. Enzyme and bacteria cleaners present an alternative to harsher chemical solutions, like solvents and strong acids or alkalines. They are more user-friendly than products with extreme pH. The process by which enzyme and bacteria cleaners work is important to understand. When a bacteria product is applied, the microorganisms, which have been dormant, begin to grow and digest the waste that is present and is used as their food source, and the bacteria in turn multiply. Since bacteria does not have a mouth, they break down and metabolize waste by producing enzymes. The waste that has been broken down is now small enough to be absorbed through the bacteria cell wall. Once the waste particles are inside the cell, they can be broken down and used as a fuel and energy source, allowing the cell to reproduce again and again, thus repeating the process. As long as organic soils are available as a food source, the process will continue. Straight enzyme cleaners are products that contain only the enzymes, which have been separated from the bacteria that produce them. These products also break down soils like grease, starches, and proteins. Once the enzymes have done their job, they are used up and cannot reproduce themselves. In turn, they will not be able to degrade any more waste. Enzyme and bacteria cleaners are currently used primarily for drain line cleaning and odor control. They can be applied once for a specific odor problem or organic waste clog, or they can be incorporated into an ongoing maintenance program to minimize waste buildup and reduce the need for costly pumping. Solvent cleaners are particularly effective for the removal of organic soils like oils and greases. The solvent removes the soil from the surfaces. The common solvent cleaners and degreasers that you'll encounter are water-soluble glycol ether, which is commonly known as butyl, allows water-based solutions to remove oily soils more effectively. Glycol ether solvents are unique because they can be dissolved in oil or water. An example of this water-soluble glycol ether solvent would be a booster that you would add to your carpet cleaning pre-spray to remove oily residue on the fabric. D-limonene solvents are derived from orange peel extracts. This has been a commonly used solvent for rapid penetration of organic and baked-on soils. Petroleum distillates. This type of solvent is designed to remove greases and oils from surfaces where water cannot be tolerated. An example of where you would use this type of solvent would be metal surfaces, like a motor. Synthetic biodegradable solvents. This is a unique blend of solvent that is biodegradable. They can be diluted with water and could be used for dissolving asphalt, tar, oil, and grease. Now that we've covered the basics of cleaning and the functional components of cleaners, it's important that you have a good understanding of the factors involved in selecting a cleaning product. In Part 2, we will discuss the 10 factors of cleaning.